Hi students, today we are going to see 12th standard applied mathematics unit 1 modulo arithmetic and modulo operations. Unit 1 first topic modulo arithmetic. Modulo arithmetic means arithmetic with reminders. Before going to that modulo arithmetic, let us see what we have learnt in lower classes, division algorithm. In division algorithm, we are having two integers. Let A and B be any two integers. Then we can find Q and R such that A is equal to BQ plus R. That is, when we divide A by B, we get two values Q. Q is called quotient and we get a remainder R. And this R lies between 0 and less than B. A is called dividend, B is called divisor, Q is called quotient, and R is called remainder. With this brief introduction, we are going to modulo arithmetic. Modulo arithmetic is the arithmetic of reminders. Let A and B be any two integer. Okay. Then we write A mod B and it is equal to R. The meaning here is, when we divide A by B, we get some quotient. We are not going to concentrate on quotient. We are going to concentrate only on the remainder. So A mod B is equal to R. That is, when we divide A by B, we are going to get the remainder R. And we have the condition on R that says that 0 less than or equal to R less than mod B. Is it clear? So A mod B is equal to R. The meaning is, when we divide A by B, we are going to get a remainder. The remainder lies between 0 and less than modulus of B. Suppose 15 mod 4. What is 15 mod 4? That is, we have to divide 15 by 4. Then the quotient is 3 and remainder is also 3. So it is 3. Suppose we are going to write 7 mod 11. 7 mod 11. So we are going to divide 7 by 11. So the quotient is going to be 0. The remainder is going to be 7. That is equal to 7. What happens when both the values are same? 7 mod 7. We have to divide 7 by 7 and the remainder is going to be 0. So this is the basic concept for mod. Modulo. Modulo means remainder. Different cases of modulo arithmetic. What happens when x is greater than 0, y is greater than 0 and x is greater than y? We take x greater than 0, y greater than 0 and x is greater than y. In that case, x mod y will be equal to r. 0 less than or equal to r less than y. Here we are not using modulus because y is going to be positive. So we are not going to concentrate on the sign of your y. Example, if we take for all the 4 categories, we are going to take same values so that we can identify where we are changing the concept. We take 12 mod 5. So we divide 12 by 5. When we divide 12 by 5, 2 5s are 10. So balance is 2. So it is 2. So 12 mod 5 is 2. Clearly we can see that 0 less than or equal to 2 less than 5. What happens when x is greater than 0 and y is less than 0? Surely x is positive, y is negative. So x is going to be greater than y. So we take 12 mod minus 5. We can write this as 12 mod minus 5 also. So now we are going to divide 12 by minus 5. I am going to divide 12 with minus 5. So what will be your quotient? Minus 2. Minus 2 into minus 5 plus 10. So subtract, the answer is 2. So 0 less than or equal to 2 and less than modulus of your y value. Modulus of minus 5. Third one, when x is less than 0, y is positive. X is negative, y is positive. So we take minus 12 mod 5. So we are going to divide minus 12 with 5 plus 5. So how to divide now? Now the quotient will be minus 3. Minus 3 into 5 minus 15. Sign change. So answer will be 3. So this is 3. So 3 lies between 5. And the last case, both are negative. X is less than 0, y is also less than 0. So we take minus 12 mod minus 5. I divide minus 12 with minus 5. What will be the quotient now? Three into minus 5. It will be minus 15. Sign change. So the remainder will be 3. So 0 less than or equal to 3 less than modulus of minus 5. Modulus of minus 5 is plus 5. Is it clear? So in this mod, the remainder we make it to be positive always. And it is going to lie between 0 and less than the divisor. Less than the divisor. The special cases are, first one, what happens when x is equal to y? When x is equal to y, x mod y is always 0. Because X and Y are equal. When you divide X by Y, there is no remainder. Remainder is going to be 0. When X is less than Y and X and Y are positive, X is less than Y, that is Y is greater than X. In that case, X mod Y will be equal to X itself. For example, if we take 5 mod 7, 5 mod 7. So we divide 5 divided by 7. So 0, 0, the remainder is going to be 5. Now we are going to see certain properties on mod. A plus B mod M will be equal to A mod M plus B mod M. And same way, A minus B mod M will be equal to A mod M minus B mod M. And product A into B mod M will be equal to A mod M into P mod M. And this property can be extended to any numbers. Suppose if you are going to have A1 plus A2 plus A3 plus etc. AN mod M. This can be easily calculated with A1 mod M plus A2 mod M plus A3 mod M plus etc. AN mod M. And same way for multiplication also. If multiplication A1 into A2 into A3 etc. AN mod M can be rewritten as A1 mod M into A2 mod M into A3 mod M etc. AN mod M. Okay, suppose in the calculated values of these answers, if the remainder is going to be more than your M, then we have to apply the formula. Again, we have to divide by M and take only the remainder. The remainder should be always less than M and it should be always positive. Now we are going to see congruence modulo. Let A and B be two integers greater than 1. Then A is said to be congruent to B modulo N. A is said to be congruent to B modulo N. If and only if N divides the difference of A and B. And we will write A is congruent to B mod N. If there exists an integer k such that A minus B equal to Kn. The meaning is N divides A minus B, or N is a factor for A minus B. And in this expression we are having three values. Okay, One is A, the other one is B, and the third one is N. And we have a condition on N. N should be strictly greater than 1. That is very important. The value of N should be strictly greater than 1. And in the expression A congruent to B mod N, just now I said we are having three values A, B and N. Given any two values, we can calculate the unknown. For example, in the first expression, it is given A is congruent to X mod N. Here, we are supposed to calculate this X. In the second expression, X is congruent to B mod N. And here we are going to calculate the value of X, which is supposed to be the dividend. And in third one, A is congruent to B mod X, where X is going to be the divisor. Okay, now we are going to solve the first format. A is congruent to X mod N. Here we are going to find the remainder X. So we are taking an example 49 congruent to X mod 8. So by the definition of the congruence class, 49 minus X must be divided by 8, which implies 49 minus X should be because 8 is going to be a factor for 49 minus X, 49 minus X should be multiple of 8. So we take 8 lambda, where lambda is an integer. Lambda is an integer, integral multiple only. But we are going to concentrate only on X. So what we do now? We take minus X to the other side and bring 8 lambda to the left side. So we get 49 minus 8 lambda should be equal to X. That is, X is equal to 49 minus 8 lambda. Now we can give values for lambda, different values. It can take, lambda is going to be an integer, okay? For integer, lambda can take any value between minus infinity to plus infinity, minus 3, minus 2, minus 1, 0, 1, 2, etc. The first one we take X is equal to 0. Sorry. We take lambda is equal to 0. Lambda should be 0. What happens to your X? X is equal to 49 minus 0. That is equal to 49. What happens when lambda is equal to 1? Then X is equal to 49 minus 8 into 1. That is equal to 49 minus 8. That is nothing but 41. 49 minus 8 is 41. What happens when lambda is equal to minus 1? X is equal to 49 minus 8 into minus 1. So 49 plus 8. It is 57. So now itself we found three values for X. And it is not the only values. By giving values for lambda 2, we will get another value for X. Giving lambda to be equal to minus 2, we get another value for X, and it will go on. So now for the time being, your X is nothing but 41, 49, 57 and so on. So this is type 1. This is type 1. Of the three value, we are finding the remainder here. Now we are going to see the second one. x is congruent to b mod n. Now we are going to concentrate on the dividend. What are the values of x which will satisfy this congruence class? X congruent to b mod n. How to solve this type of expression? For this we are taking an example. X is congruent to 12 mod 7. X is congruent to 12 mod 7. So in that case, x minus 12 is divisible by 7, which implies x minus 12 should be equal to 7 lambda, where lambda is going to be an integer, which implies x is equal to 12 plus 7 lambda. We take that minus 12 to the other side. So 12 plus 7 lambda. So by giving the value for lambda, different values of lambda gives different values for x. So as usual in the previous case, we take a lambda is equal to 0. So what happens to your x? X is equal to 12 plus 7 into 0, which is nothing but 12. We take lambda is equal to 1. X is equal to 12 plus 7 into 1. So 12 plus 7, that is equal to 19. Lambda is equal to minus 1. X is equal to 12 plus 7 into minus 1. 12 minus 7, which is nothing but 5. We can take lambda is equal to 2. In that case, x is equal to 12 plus 7 into 2. 12 plus 14, that is nothing but 26. Lambda is equal to minus 2. Your x will be equal to 12 plus 7 into minus 2. 12 minus 14, that is equal to minus 2. And giving the other values for lambda, we will generate the values for x. So your x will be minus 2, 5, 12, 19, 26 and so on. Now we are going to see equivalence class or congruence class. Let a and n be integers, n greater than 1. The congruence class of a mod n is denoted by a within square bracket suffix n and is defined as the set of all those integers which are congruent to a modulo n. The other words, it is a set of all integers which when divided by n leaves the remainder a. Do you understand? Suppose, for example, congruence class 3 under modulo 7. Congruence class 3 under modulo 7. It represents all those integers when divided by 7 leaves the remainder 3. So what are the elements which will be present here? The first integer after 3, which when divided by 7 leaves the remainder 3, is going to be 10. Then 17. Then 24. Then 31. So this is the example for the congruence class, modulo of a number. If n is a integer, congruence class A under modulo n is the set of all integer b such that b minus a is equal to k n, where k is an integer again. Now we are going to see property of exponent in modulo arithmetic. If a is congruent to b mod n, then a power k is congruent to b power k mod n for all k belonging to natural number. What are natural numbers? Numbers which start with 1. 1, 2, 3, 4, 5 are called natural numbers. So this is the property of the exponent in modulo arithmetic. I repeat once again. If a is congruent to b mod n, then a power k is congruent to b power k mod n for all k belonging to natural number. We will try to do one problem here. Find the value of 6 power 12 mod 7. 6 power 12 modulo 7. We know that 6 is congruent to 6 mod 7. Correct. 6 is congruent to 6 modulo 7. What happens to 6 square? 6 square is 6 into 6, 36. So 36 is divided by 7. We take the division. So it is 1. So 6 square is 1 mod 7. But we are supposed to calculate 6 power 12. So I raised to the power 6 square, I raised to the power 6. It is congruent to 1 power 6 modulo 7. So left hand side it is 6 power 12. Right side 1. 1 power 6 is always 1 again. So 1 mod 7. So this is the application of exponent in modulo arithmetic. The most admirable thing in modulo arithmetic is addition modulo and multiplication modulo. Okay, we are going to see addition modulo m. Let a and b be two positive integers. The addition modulo m denoted by plus suffix m, where m is any positive integer is defined as a addition modulo m b is equal to a plus b modulo m, whenever a plus b is greater than or equal to m. When the sum of the two numbers a and b is more than m, then it is taken as a plus b mod m. Suppose if a plus b is less than m, we take the answer as a plus b itself. We will say one example here for both the condition. Find addition modulo 7. Addition modulo 7. It is denoted by plus suffix 7. So now we are going to calculate a and b are going to be 12 and 6 respectively. Now 12 addition modulo 7 6. Which is equal to 18 mod 7. Now the 18 is more than 7. So we divide 18 by 7. We divide 18 by 7. 2 7s are 14. So balance is 4. So 12 addition modulo 7 6 is equal to 4. So this is the answer. Now another example, find addition modulo 19 where a and b are 8 and 6. So we are going to calculate 8 addition modulo 19 6, and this is equal to 14 mod 19. Now the 14 is less than 19, so we take the answer as 8 plus 19 6 is equal to 14. So the answer is very simply 14. Here we are not going to divide by any value. Why? Because 14 is less than 19. But here we divided. Why we divided here? Here 18 is more than 7 and this 18 should be less than 7. So we divide 18 by 7 and take the remainder. Now we are going to see subtraction modulo m. As usual, as we already seen, addition modulo m. Now we are going to see subtraction modulo m. Let a and b be two positive integers with a greater than b. The subtraction modulo m denoted by minus suffix m. Where m is any positive integer is defined as a subtraction modulo m b is equal to a minus b mod m. If a minus b is greater than or equal to m, and it is simply a minus b if a minus b is less than m. We will see an example here to explain this concept. We are going to see subtraction modulo 8. Subtraction modulo 8. How we write subtraction modulo 8? Minus 8. A is going to be 15 and b is going to be 4, and clearly we can see a is greater than b. Now 15 subtraction modulo 8 4 is equal to 15 minus 4 mod 8. Why? Because 15 minus 4 is going to be 11. 11 is definitely going to be greater than 8. So how to find the answer? We divide 11 by 8. So 1 8s are 8, balance 3. So it is equal to 3. Therefore 15 minus 8 4 is equal to 3. Another example, subtraction modulo 12 with a is equal to 20, b is equal to 12. And here the condition is also satisfied, a is greater than b. A is greater than b. Now what happens to this? 20 subtraction modulo 12 12, which is equal to 20 minus 12 modulo 12, which is nothing but 8, because 8 is less than 12. As 8 is less than 12, we take the answer as such. Now we are going to see multiplication modulo m. Let a and b be two positive integers. The multiplication modulo m is denoted by multiplication suffix m, where m is any positive integer. It is defined as a multiplication modulo m b is equal to ab mod m. If a is greater than or equal to, ab is greater than or equal to m, and it is equal to ab if the product ab is strictly less than m. So we are going to see example, multiplication modulo 8, a is given to be 5 and b is given to be 7. So we are going to calculate. Five multiplication modulo 8, 7. Clearly 5 into 7 is nothing but 35, which is strictly greater than 8. So this is equal to 35 mod 8. So 35 is greater than 8. So we cannot leave the answer as such. So we write 35 divided by 8. 4 8s are 32. Balance is 3. So 5 multiplication modulo 8, 7. Answer is 3. What happens if the product is less than n? Multiplication modulo 6. Here a value is 2, b value is 3. So we find the multiplication modulo 6 of the product 2 into 3. Now 2 into 3, here also it is going to be 6. 6 is not strictly less than 6. So we get 6 divided by 6 mod 6. 6 is divided by 6. So answer is 0. So 2 multiplication modulo 6, 3 is equal to 0. So with this addition modulo and multiplication modulo, we are having a strange thing. In mathematics, we usually have is it possible to have sum of two integer to be equal to 0? Two positive integer to be equal to 0? Where a and b are going to be positive. A is strictly greater than 0, b is strictly greater than 0. Can you make it the sum of these two positive integer to be equal to 0? Definitely not. We cannot make it to be equal to 0. But in addition modulo, we can make it to be equal to 0. We can take 2 and 5. 2 is strictly greater than 0 and 5 is also strictly greater than 0. Both are going to be positive value. What happens when it is going to be addition modulo 7? 2 addition modulo 7, 5. This is nothing but 2 plus 5 mod 7. So 2 addition modulo 7, 5 is equal to 7 mod 7. So divide 7 by 7. The answer is 0. So with the addition modulo, sum of two positive integer can be equal to 0. Sum of two positive integer will be equal to 0. And the same way, product. We have already seen one example. 2 multiplication modulo 6, 3. 2 is a positive number. 3 is also a positive number. Product of these two, it is 6 mod 6. What is the answer for this? It is 0. But in real numbers, the product of two values is equal to 0 provided any one of the value to be equal to 0. Is it clear? But here in congruence class, multiplication modulo, we are having two positive integers. 2 is a positive integer, 3 is also a positive integer, but their product is going to be equal to 0 under multiplication modulo 6. This is not only for 6, it can be for any multiplication modulo values.